Have you ever wondered what's really going on inside your body when you get sick? Well, today we're going on a journey deep into that microscopic world. We're going to follow the life story of one of the most amazing cells you have, the T cell. Seriously, think of it like a special agent, part highly trained assassin, part battlefield commander, all rolled into one tiny package. And its job is to keep you safe from, well, pretty much everything.
So, here's our game plan. We'll kick things off by seeing where these T cells fit into the big picture of your immune system. Then we'll follow them through their insane basic training, figure out how they spot an enemy, see how they get the green light to attack, explore the different jobs they do, and finally uncover how they give you lifelong memory of past infections.
All right, let's jump right in. To really get our hero, the T cell, we first have to understand the battlefield. And that means knowing about the two main branches of our immune system.
Okay, so you've basically got two lines of defense. On one hand, there's your innate immunity. This system is ancient, it's the first responder, and it is brutally fast. It sees general patterns on bad guys and just attacks, but it doesn't learn and it doesn't remember. On the other hand, you've got adaptive immunity. Now this is where our T cells live. It's a little slower on the uptake, taking days to really get going, but it is incredibly specific, can recognize a nearly infinite number of threats, and this is the most important part. It remembers. That memory is its absolute superpower.
So, how in the world does a cell get to be this smart? Well, every elite soldier needs to go through boot camp, right? And for a T cell, that training ground is a very special, very exclusive place.
Meet the thymus. It's this small organ tucked away right behind your breastbone. You can think of it as the ultimate elite university where T cell cadets are made. They show up as total rookies from the bone marrow, and then they have to survive this just unbelievably tough selection process to even have a chance of graduating. And when I say tough, I mean it. Check out this curriculum. First, the body just cranks out a massive army of cadets. Then, each one literally shuffles its own genes to build a completely unique weapon, its T cell receptor, or TCR. But then the tests begin. Step 3 is positive selection. Can you recognize our own body's communication platform? If not, you're useless, you fail. Step 4 is negative selection. Okay, so you can recognize our own cells, but do you react too strongly? Are you a potential traitor who might cause an autoimmune disease? If so, you're a danger. You fail. This whole process is so intense that over 95% of cadets don't make it out alive. It's incredible.
And this diagram just lays out that whole journey perfectly. You see them start out in the bone marrow. Then they travel to the thymus for that brutal training, and the tiny faction that actually graduates emerges as mature but still naive T cells. From there, they ship out to your lymph nodes and your spleen, basically just patrolling the body, waiting for the call to action.
All right, now we get to one of the most beautiful parts of this whole story. A T cell doesn't just see a virus floating by. No, it's way more sophisticated than that. It needs intelligence delivered to it in a very, very specific way. To get this, you just need to know two key terms. First is antigen. That's just a fancy word for a piece of the enemy, like a little fragment of a virus or a bacteria. Second is the MHC. You can think of MHC molecules as tiny little platforms or bulletin boards on the surface of your cells. Their whole job is to hold up these antigen fragments so T cells can come by and inspect them.
Now, this slide is critical because there are two main intel channels. On the left, we've got MHC class 1. This is on almost every single cell in your body, and its job is to show what's happening inside that cell. So if a virus gets in, the cell chops up bits of the virus and puts them on display. It's like a distress signal screaming, "Help, I'm infected, you have to kill me," to an assassin T cell. On the right, MHC class 2 is different. It's only on professional antigen-presenting cells. These guys are like scouts. They go around gobbling up invaders, and then they show the pieces to commander T cells to organize a huge system-wide response.
And that brings us to this aha moment, the principle of MHC restriction. The image shows it perfectly. For a T cell to get triggered, its unique receptor has to bind to both the little piece of the enemy and the specific MHC molecule holding it. It's like a key that only fits into one very specific lock. This amazing double-check system is what makes the whole T cell response so unbelievably precise.
So a T cell has found its target. You think it's time to attack, right? Well, not so fast. Your body has an incredible safety switch built in to prevent any friendly fire incidents. The best way to think about it is like a missile launch that needs two different keys turned at the exact same time. Signal 1 is that super specific recognition we just talked about, the T cell's receptor locking onto the antigen. But that's not enough. To really go, it needs signal 2, a second confirmation handshake from what are called co-stimulatory molecules.
And this diagram just nails why that second key is so vital. Look at the bottom half. If a T cell gets signal 1 from just a regular body cell, but it doesn't get that second go signal, which, by the way, only a professional antigen-presenting cell can give, it doesn't attack. In fact, it does the opposite. It gets shut down on purpose. This is such a critical safety feature to stop T cells from accidentally attacking your own healthy tissues.
Okay, so once a T cell gets both of those signals, it is officially activated. It starts multiplying like crazy, and then it specializes. So now we're going to meet the two main divisions of the T cell army. This is the fundamental division of labor. First, you have the CD8 plus T cells. These are the assassins, the killers. Their one and only job is to patrol your body, find any of your own cells that are infected or cancerous, and just eliminate them directly. Then you have the CD4 plus T cells. These are the battlefield commanders. They don't do the killing themselves. Instead, they coordinate the entire immune response, activating other cells, telling B cells to make antibodies, or ordering macrophages to get more aggressive.
What I love about this slide is that it shows you the real diversity of roles here. Way over on the left, you can see that CD8 killer in action, basically telling an infected cell to commit suicide. But then look at the CD4 commanders. They're not just one type of general. They specialize into all these different roles. Some become helpers that fire up other cells for cleanup duty. Others focus on helping B cells pump out antibodies. And some even become regulatory T cells whose job is to actually calm everything down once the fight is over.
And that brings us to the final chapter in our T cell story. And honestly, the single most powerful feature of your entire adaptive immune system. So what happens after the battle is won and the infection is cleared out?
Well, most of the T cells that were created for that one fight will actually die off. But a small elite squad of them gets to stick around. They become these long-lived veterans that we call memory T cells, and they carry the experience of that one specific battle with them for years, sometimes for your entire life.
These veterans create a reserve army. Some of them, called central memory cells, hang back in your lymph nodes, ready to launch a massive and super-fast response if that same bad guy ever shows up again. Others, the effector memory cells, keep patrolling the front lines, acting as sentinels. This right here is why you usually only get something like chickenpox once, and it's the exact same principle we use for vaccines. We show your immune system a safe version of an enemy, so you can build up a powerful army of these memory T cells without ever having to get sick in the first place.
You know, when you boil it all down, it comes back to this one simple but really profound idea. Your adaptive immune system, with these T cells as its stars, has the incredible ability to learn from the past, all to better protect your future. So from that grueling education in the thymus to becoming a precise killer or a master strategist, the T cell is just an amazing testament to the elegance of our own biology. It's building a living, evolving library of every single pathogen you've ever conquered, a library of survival, written right into your own cells.